Hey, welcome back, AP Calculus students. Today we're looking at 7.5 logistic growth. So they say that the dp dt is equal to kp for k is greater than 0. So k, oh, here we have it over here. So k is the rate, p represents the population, and m represents the maximum capacity of that population. So if we have, I don't know, like dogs in a certain area, like wild dogs, there's a limit on how many dogs that area could sustain given like the amount of resources, right? So if there's not enough food, we can't sustain more than a certain amount of dogs, or if there's not enough area, we can't fit that many dogs into that area. So there's definitely a limit. So that max represents the limit of population. All right, so for the example we're looking at here, we're showing the growth of a bear population. So it says dp dt, the derivative of the population with respect to time, is 0.008 p times the quantity 10 minus p. All right, so just from the equation given, we can determine these three things. So what is the capacity? All right, so notice the m minus p. So the maximum amount of bears we can have is 100 bears, right? That we're just identifying the m. The second is asking us, when is population growing fastest? So the thing to remember here is that p times parentheses 100 minus p, if we multiply this whole thing out, we're going to get a quadratic, which means we have a parabola that looks like this. And what we know about parabolas is that it's always, the maximum is always halfway between the two ends, right? So if the population is 0, when p is 0, that's one end. And then the other end would be the whole thing would be 0 when population is 100. So we know the vertex is located halfway between 0 and 100, and that would be at 50. Right, so it's at 50. So when it's growing fastest, it's always half of the maximum population. Okay, and then part 3, what is the rate of change when growing the fastest? So all we have to do is plug in a 50 into our equation, right? Because this is giving us the rate of change of our population, the derivative of our population. So 0.008 times 50 times 100 minus 50 is 50 again. And we get 20. And that would be 20 bears per, there's not a T in there, bears per bear? I don't know, 20 bears per whatever our time is. Okay, on to the next one. So this is like really the big idea here, and it doesn't, again, this stuff may or may not be on your exam at the end of the year, but it's good to go over it. So it's saying that the solution, if we're trying to find the solution for that, if we're trying to find the actual population, it's represented like this. So if we're given an equation like we had here with the bear population, right, we can take that and figure out the overall population by using this form. So m over 1 minus a, e to the negative mk times t. All right, so this example here is pretty straightforward. It's plugging in, but there's one step that's necessary that's not so obvious. Okay, so if we're looking at this, kp times m minus p. So we don't have a k, right? But we have a p. This may be our m, but then we have something times p, so it's kind of messing it up in this parentheses. But we can do one thing to make it look exactly like we want it to. dp dt equals kp times m minus p. And what that is we're going to factor out the 3.125 times 10 to the negative 7. So remember, when we're factoring stuff out, we're dividing by it in the parentheses and pulling it outside. So dp dt, we're going to take it outside. I'm going to take 3.125 5 times 10 to the negative 7 outside with our p. But we're going to have to divide it out from each part. So 0.1 divided by negative 3.7, that's going to be, okay, let's say 0.1 divided by I'm going to put parentheses 3.125 times 10 to the negative 7 gives us 320,000. 320,000. Okay, and the good thing about it is when we divide this by itself, it's gone. So we have minus p. Now this form looks a lot more like the form we wanted in, right? So here's our k now. Here's our p. This is our m, and there's our other p. Okay, so from here we can start filling in this population thing. So population equals, our m is 320,000. 320,000 over 1 minus, and we don't know what our a is. We have our e and the negative. Remember when we multiply negative m, or multiply m by k, m times k is 0.1, or you can also do it out if you want to. So it's 0.1 times our t. All right, and we have an initial condition here, so we can find what our a should be. So we're going to plug in our 0 and 12,800 into our t. 0 in for our t and 12,800 for our population. So 12800 equals 320,000 over 1 minus a, e to the negative 0.1 times t is 0, right? Because we're looking at times 0. So this whole thing here, we're solving for a. So we're going to do 12800 320,000 over, now for this part, that's going to be 0, right? 0 times 0.1 is 0. So e to the 0 is 1. So we just have 1 minus a. And we got to solve this. So we're going to multiply by 1 minus a. Both sides. So these cancel out. And then we get 12800 minus 12800. A equals 320,000. Sorry, we're running out of room here, but then we subtract. And then divide, right? So let's see here. 320,000 divided by 12800, or sorry, minus. And then divided by 12800 is 24. So a is going to be actually negative 24, right? Because then we have this negative sign. So a is negative 24. And then we just fill in this whole thing. So 32000 over 1 minus, we know a is negative 24, so plus 24. And then we're going to do e to the negative 0.1 t. So the goal is to fill in our information into our formula, and to end up at the very end with just p's and t's. Right? We'd fill in our m's and our k's and our e. Okay, so that would be the form for our equation. Again, I'm not sure how much this will be on the test. Probably not very much, if at all, but it's good practice, and your assignment is pretty short, so hopefully you'll be able to complete it no problem. And this brings us to the end of Unit 7. Yeah, so we'll be moving on to Unit 8 soon, which is more of the anti-differentiation stuff and integral stuff, but we're going to start getting into more applications like volumes and areas and stuff like that. So for those of you who are in engineering, that'll be something to help you in that field. Okay, good job.